Hello, everyone. Thank you for joining me to this talk. I'm Nicolas Lade. I'm working at Berger-Levrault with Benoit and Kylian on this project. So my presentation is about mining software repository and how we are doing it with Pharo. So I want here to give you an introduction about mining software repository. In general, I will not go in depth with it. And I want also to give you the specificity of Berger-Levrault regarding this field. We developed a tool called Git Project Help, so I want to give you a brief tour of what you can do with this tool if you would like to use it. And then I will talk about what's next for it as a next evolution. So what is mining software repository? It's, as you know, most of the development teams today are relying on what we call Git social platform. There are platforms like GitLab, GitHub, Bitbucket, and they allow the developer to push their code and build them with commits, merge, stuff like that. But they also add some social feature. You can see it here, for instance, where the developer can discuss the pull requests they have in GitHub by making comments, suggesting new code, stuff like that. So they have social interaction with each other. That's why we call them social platform. They also store the historical information of the software development. So through the activity of the development, like we see here, we can have the commit distribution over time. So you can have an idea of what has happened during the development cycle of your project. Mining software repository is a field in academia that has been studied for over the last 30 years. It's about providing tools, approach, methods on how to extract those data from those kind of platform and how to analyze them. So as a different study, over the last 20 years, we have studied that we're focused on how code how code smell impact the code development, some of them about code review, which classes were more prone to changing the defect, and so on and so on. And you can also analyze the entire life cycle of the development cycle of a project. There is, of course, tools that we found in the literature. We divide them in 4 categories. We have those general mining purpose tools like PyDriller and Gitminer. Tools that are more specifically tuned toward the specific artifacts, for instance, Jasper, and ModelMine. And you also have tools to store data in the long term, like Pandora and Software Heritage. And finally, tools for computing metric, like LinearB. So, okay, now that we know that, how can we use this in Berger-Levrault context? So, you have to understand that Berger-Levrault, it's a group composed of international companies that are software editors. So we have companies that work in different fields, education, health, public administration, stuff like that. And they have been acquired by Berger-Levrault through the last 30 years. So some of them are in France, in Spain, in Morocco, and they are using different kind of technology. The software have been developed in Java, C#, TypeScript, etc. And so, of course, they will also have their own Git social platform. And we have currently 3 of them, GitLab, Bitbucket, and Azure DevOps. Fortunately for us, they managed to all use the same management software system, a project management system, sorry. And we are actually using Atlassian Jira to manage our tickets. So every time you will have an activity to do on the project, for instance, there is a bug, a new feature to code, you will declare a ticket, and they are using the ability of Jira to do sprints through Kanban. This is the figure that you see below, to manage the ticket inside sprint. And of course, they can also declare when will be the next release, what will be the due date, stuff like that. So in this platform, it's mostly used for project manager, not for developers. But the developer will go inside this platform to get the task, basically. And to connect those 2 platforms, we are relying on what is called ticket keys. So every time there is a new ticket in Jira, we assign this ticket to a specific key. So for instance, here, the AV1 key. And you will see that this key is also mentioned inside the merge request name or the commit name if they are associated to the specific activities of, like in this case it's in French, but it's a problem with something in the code. So we have 3 platforms, and we want to mine them. We want to mine them to get the data of what's happening inside the development throughout the entire group. So first, we ask ourselves, how do we mine this efficiently? What would be the proper way to do that? Then we also have to consider that if we want to build metrics for those platforms, we will have to find a way to implement those metrics, not for each platform specifically, but for all platforms all at once. And finally, if we want to connect the data that is in Jira, we need to connect it to the data that is inside the Git social platform. So we will have to find a way to connect those 2 data models together in order to make the analysis. So we decide to go and use model-driven engineering with Pharo and Moose to actually implement this tool. So I will now introduce you to Git Project Health. So it's a framework that we are building in Pharo. I think Pharo 11 and 12 are compatible to extract and analyze the data from Git social platform. So if we go back to the category of tool, it's a tool for general mining purposes and to compute metrics. We made 3 main contributions with this tool. We have a unified meta model for all of the platform, the Git social platform. And we have also a framework to customize new metrics that are computed from the model and not from the data of each platform specifically. And we also are relying on meta-model connectors, which is an ability in Moose to connect entities between 2 different models. So you can have a meta-model that was developed for Jira independently, and you can connect it to the meta-model of the Git Project Health. So if you would like to use this tool, there is a link through the QR code. So there are 3 key features inside Git Project Health. You can extract the data from those platforms, and you can import them inside the meta model. I should have a pointer, but this is like the snippet of code over there that lets you do that. But I will have a quick demo after that. There are also pre-built visualization and metrics that you can compute, and you can bring platforms together with the meta model connection. So speaking about the meta model, I have here a simplified version of the meta model that we are using, and you can see that you will find the main concepts that are known through all the platforms. So you will find user, metrics, commits, the fact that there is a project is composed of branches, etc., etc. But when we build this meta model, we want this to work for all the platforms that we encounter. So we have to make decisions. First decision that we are making is about naming the entities of this model. So for instance, as a simple example, merge request is the name used inside the platform of GitLab, but in GitHub it's called pull request. So here we decide to name it with the standard find in GitLab, but it's actually representing the same things. There is also new relations that are not typically found in those platforms. So you will think that a commit is always linked to a user of this platform, but it's actually not the case. A commit is linked to a commit author, and an author is not necessarily a user of this platform. Here we have decided that a user is always linked to a commit, so it's easier for us to track the activity of a user through the different project that is making. It can be from different platforms, it can be from the same platform, as long as we decide that it's the same user. And finally, some of the tools that we mentioned earlier, they don't necessarily go they don't necessarily have a fine granularity when it comes to modeling the data from those platforms. Here we decided that we want to go as far as possible into modeling what has changes, for instance, when you have a commit. So instead of stopping at the diff information, we go to the diff ranges and to each line of code that has changed in these diff ranges. So of course, it makes for a lot of data. So you don't have to go that far when you are using our tool. You can stop at the commit representation, but if you want to go further, you can also download the changes and stuff like that. All right. About how we import the data, there are the concepts of the model, of course, but you have to put data inside this model. So we are using what we call importer to do that. An importer is at first a generic classes that we can extend to specify which platform we want to extract the data from. So there are the platform of GitLab, GitHub, and Bitbucket in this case, currently in the tool. And the good thing is that those importers are linked to API, and those API are separate projects. They are built independently. So if you would like to use, for instance, the API of GitLab from Pharo outside of Git project itself, it's totally possible. It's an independent package. And we are releasing those packages inside the group of GitHub evref that I put the link here. Currently, we have GitLab. I think GitHub, Bitbucket, it's ready, and we should have GitHub on the way. About the meta-model connection, so I know that not everybody is familiar with meta-model, moves, and how it works, so we try to make it as simple as possible. Every model that we are using in this project is a submodel of, is a moose model. So it means that they are sharing the same characteristic. When we build the model of Git that is used inside the Git project itself, it's actually using the same tools that we use to build the model of Jira, even though it's a completely different project. And so when we want to connect those models, we are actually building what we call a model connector. And this connector is using the entity that we want. We pick entity from Git and from Jira. We are able to link them together through relation. So how is it declared? It's actually super easy. You declare two methods, one that defines the classes that you want inside your connector. So here we want to use classes from the Git model that are the merge request, the commit, and one classes that is from Jira, which are the issues. So they are remote entities. They are not declared inside the connector. The connector is only using those entities. Then you can declare a relation between those entities by just saying, okay, there is for instance, a merge request that is linked to a Jira issue, and a Jira issue is composed by merge request and stuff like that. So you can see the meta-model connector as a super meta-model above the two that you have declared so far. And when you want to connect the entity, you create a relation between them, and you declare how the model should compute this relation. So here the relation is computed by the fact that, as I mentioned earlier, a issue, ticket, whatever, as a key, and if this key is present inside the message of a commit, then we should make a link, and this is the snippet of code that is right above that do that. All right, so I will try to make a quick demo of how does it looks like in Pharo. This is where the things are getting out of hand. All right, so because it's only retrieving data, it's not very visual, so I will try to show you that we are actually retrieving the data through a log system. Every time we are gathering data from the social platform, we try to log as many things as possible so you know that something is happening. So here, I will declare a new model that I call ESUG 25. And in this model, I will set up, not in this model, but I will also set up the API of GitLab. And I will give this API to Git importer. And I will also give it the model that we are using. So the first thing, the first thing I want to do is to look at a project called Inkscape. So it's a GitLab project. I think I have the pages here with many activities. It's very popular. And I will try to import this project first. So as you can see here on the log, I don't think it's big enough, but I'm gathering the project. I'm importing the pipeline of this project. So actually the last 20 pipeline, because it can be like thousands of pipelines through the years of the project activity. Some of the users that are declaring those pipelines, and then the repository. So here we are actually doing some lazy download of the data, which means that we are not downloading everything all at once. So the user of Git project health can select what he wants to download. Here we created the entity of Inkscape, inside the model. We've imported 20 pipeline and the user creator of this project. But as you can see, the repository is kind of empty. We only have the branches. If I go to the branches, there is nothing, just a link to go back to the repository. So I will now put some more data inside. I will start by gathering the commits from this project, but only from two dates, June, like last day of June and the 2nd of July. So it has been like 53 commits over there. Okay, so that's something. Those commits, I can also ask to import the creator of all of those commits, so it will be like the user. Like I mentioned earlier, the author of the commit is not necessarily the user, so I will try to retrieve which user was made those commits. So you can see in the log that we are looking for those users by their name or by their ID and try to import them inside the model. Okay, so now that I have this, I will try to chain those commits together. Chaining the commit is because a commit only knows his parent. He doesn't know what's next after him. So now that I've chained the commit together, I can actually watch the commit tree. So sometimes it's interesting, sometimes it's just because they are in different branches, you don't actually see a lot of it. But here, for instance, you can see that this commit over there are led to 10 subcommits, child commits. Okay, so that's one of the visualization we can do. I don't know if it's useful or not. It depends on each case, of course. We also have a way to manage users. So we build what we call a user catalog. And here I will look for a user named Curtis. So Charlotte Curtis has been a user inside Inkscape. Okay, I can ask to download the project that she worked on. So it would download those projects next. And so it throws the image when I'm doing that, but I can see that it's actually importing some stuff. But the cool thing is that we are not building a separate model for each project. So if I want to go back to the main model over there, so we see that she's working on 4 different projects, including Inkscape. If I go back to the main model, that is here, and I inspect it, you see that I have now 4 projects inside my model. So I can compute some stuff in between those projects, like what did she do actually in those projects, which were the projects that she was most active on, stuff like that. I won't do it now because it takes a little bit of time and it's not part of the demo. But another thing that I wanted to show you is that in Inkscape, we can look at the developer's activity. So here, we can see a commit distribution of what who were developing inside the Inkscape project. And there is a strange things here. We can see that there is 2 René. There is René with an accent and René with an accent a little bit after the E. So they are actually the same user. But somehow René probably misspelled his name during one of his commits. And so the platform does not know that those 2 entities are the same. Those 2 persons are actually the same user. So this is why we are unifying the user and the author in the model. So we can manage those users by using the user catalog that I mentioned earlier. So the user catalog in this case, I will look for people that are named René. I will see that I have 2 of them, and I will use a fuse function to fuse the 2 René together. Okay, and so now for next analysis, the Git project elf know that those people are the same. So it will associate the commit to a single René and not to 2 different René. You can see here that I only have 1 René left. One thing that you can do is if you close your images and you want to save those things, you can export the catalog into JSON. And you can update this catalog along the way. So that's a good thing. All right. Now I want to demonstrate that we can gather the data from different platforms. So I have here an importer for GitLab. I lost the connection. It's all right. The data was already downloaded. I have here an importer from GitHub, and I will ask him ask it to download the group of Moose technology and the group of EVRFBL. So since I have lost internet, I can show you the group of Moose technology here. You can see that there has been around 100 projects developed, and I can ask for the group quality, which is something that we've defined as if there is a pipeline in this project, that we will fetch the latest pipeline and see if it has passed or not. So in this particular group, you see that most of the projects don't have any pipeline. Is it a good thing, a bad thing? It's up to the developer to decide, of course. And some of the pipeline have failed the last time it was they were run. And we can do the same thing for EVRFBL, but I lost internet, so I won't do it. Okay, last thing I want to mention briefly is that you can compute metrics. So by running this piece of code over here, you can select the metric you want to run. You can select which project through the IDs of those projects you want to run the metric on. And you can also specify a period of 2 dates, so the start week, for example, and the end week of to produce your analysis, and the time frame of the analysis. So here, I think by default, we are averaging the results by week, but you can average them by day, month, or year. So it's up to you. The result of that is you can export them as a CSV, and I don't know if it's clear here, but I run it a little bit earlier, and I run like one metric that tells me like for close merge requests how long were them since they opened to when they were closed, and it's output in second. Here the code churn. So for all of these, for all of the commits inside the project, what was the code churns of those commits. You can use those metrics wherever you want then, because it's output as a CSV. So that's for the quick demo. We go back to the slide. Okay. So I mentioned the metrics before. Since the last time, no, I think it's the right number. So we have now 37 metrics implemented, and we also implement some metrics that are custom to our business units in Berger-le-Vros. So if you want to extend it, of course, it's possible. The framework right now is pretty simple. You have the concept of metric that can be extended to metric running on the project or metric running specifically on a user or a group of users. And the snippet of code over there is how to run those metrics. As an example, this is what we are doing with this metric right now in Berger-le-Vros. We are using them to build dashboard that gives us idea of how many commits are produced by week, how many merge requests are closed, open, merge, stuff like that. And so it will help the manager or the team leader to have an overview of the project without going to the Git social platform. Of course, they can also ask the developer of their feedback, but this gives them a quick glance of how what's going on. And we run this for over 1 year so far. So we retro-analyze all of those projects for over 1 year, and it took us something like 20 hours, I think, of computing time to do that for an entire year. And I think this is like 1.5 years, something like that. Okay, so I will conclude next. To recap, we had a problem at Berger-le-Vros that we are using different Git social platform, and we want to connect those data together in this reusable way to compute metrics and to connect also to different platforms. So right now we connect this information to Jira, but tomorrow we can also connect it to Teams, to Slack, whatever, as long as we have an API and we can provide a meta model from this platform. We can do virtually whatever we want. I talked about Git Project Health, open source project. If you want to participate or just to use it, feel free to do that. I think the concept of meta model connection can be hard, especially if you are not using model-driven engineering all the time. But as you can see here, it's kind of simple to implement. It was only like 10 lines of code to connect 2 models together. And finally, there is also this framework of metric that you can extend, and you don't have to share metric with us. You can build your metric separately in your own repo and just fetch Git project elf and run the metric with it. For future work, we want to address some limitation. Currently, it's kind of hard to maintain one global meta model for all the Git platform, especially when we have also to implement the API and the importer every time. So it gets faster as we are running into more cases that we previously handled, but it's still something painful to do. So we want to investigate if we could generate those API in Pharo using the OpenAPI Swagger protocol. If you have any experience with it, feel free to go talk to me because I'm really interested into having a tool that can do that automatically. We want also study, and I think it will be future work for us to study which metric are the most important and which metric correlate the most with a good health of a project, because we have like 42 metrics, 47, but not all of them are useful for developers. And then we also want to evaluate the Git project health against other tools like PyDriller and Gitminer, which are tools that do some that are related to us. For next evolution, we want to be able to, this is kind of hard to visualize, but once you get the idea of you can model a Git social platform, you can also model the code that is hosted on this platform. So for instance, we have the Java Famix model, which is the model of specific projects in Java. And if you analyze a project through Git project health, there is nothing stopping you to also generate the Git Famix model. And there is connectors that are already built inside Git project health to do that. But we want to be able to run it for multiple projects, not only Java, but probably tomorrow TypeScript and stuff like that. And there is also this notion of building actionable knowledge map, which is to know where the developer are actually working on this project, who is the guy that knows about these pieces of code and stuff like that. So we want to build visualization of this inside Git project health and maybe more visualization in the future. All right, I think I'm done. Thank you for your time, listening, and feel free to ask any question if you have some.
Hi, yes, nice. When you're integrating with Jira, Jira is quite flexible, so it can use different kinds of workflow. Do you have a standardized workflow for Jira there, or do you see that different teams do different things with Jira?
What do you mean by flexible exactly?
Well, in Jira, you can define your own workflows.
Yeah.
I've worked with lots of companies with many different workflows.
Yeah.
Do you have a standard one?
Okay, let me go back a few slides before. So you're right. The workflow that we have implemented so far with the connection, we connected the meta model with this idea of there will be a share key between the Jira ticket and the commits. And this is the workflow that might be specific to Berger-Lovro or to maybe other team. I think it's quite standard, but could be also very specific. If we want to add new connection ways between another model or between Jira and GitLab, for instance, it's totally possible. And you will have to define new relation when you connect the model. So if I go back here, where was it? I think it was here. Yes. So here there is a specific connection mechanism that look for the ticket's name inside the commit's name. But we can also do some other analysis. We didn't encounter any case yet, but just because we didn't doesn't mean that they doesn't have any. So yeah, for sure we can extend that if you have any use case. Yeah.
Any other question? That's it. Thank you.
Thank you.